Right, so the battery's getting low, so the video cut off there, so I'll carry on from that one. What I was saying there, basically, is that infinity is... Oh, sorry, I was saying something is 1 times greater than itself, because it is to say that in general terms it isn't simply, in general terms, greater than itself, it is itself, which is to say that it's 1 times greater than itself, because conceptually the nature of the number 1, as it comes into being after with 0, but before 2, maybe after or with 0, something and nothing coming and being together. You get the function of addition born with that, because when you only have 1 to work with, and multiplying 1 by itself continually doesn't construct conceptually other numbers. You have to get to 2 to do that, by adding 1 to itself to get 2, first of all. And so, in terms of, as far as multiplication is concerned at that level of notation, in saying something is 1 times itself, or 1 times greater than itself, because the value of numbers and what they mean in its own right in those terms is based upon the logic. In using that logical statement, using numbers, it comes full circle, and using the number 1 within that statement amounts. It's as though it amounts to. Really, the thing is logically consistent. We could say that, and there's no instance of any numbers where, really, to objectively generally say that a number is greater than itself, for example, or other than itself, it would have to boil down to the logical basis of all function in terms of notation anyway, which is difference, so like multiplication and indexing above and so on. Because all relative value, and therefore the meaning of value itself, comes down to difference, because that's the way we construct numbers, starting at 0 and 1, adding 1 to itself continually to construct the numbers in the first instance. All the higher notations in their meaning are born out of or emerge out of difference logically as a logical basis. So that a number is generally other than itself, only if it can be boiled right down to being other than itself in terms of difference, and no normal finite number is that. Even 0 is, add 1, you get a different number, take away 1, you get a different number. So it's true of infinity anyway, in the way it's not true of any other number, you see. So, that being said, then, what we could say nonetheless is still, for example, that, okay, take that on board, that even infinity plus 1 is itself, given the logical basis of value and quantity. The relativism of different values and of quantity itself is based upon, in the first instance, difference in its meaning, conceptual meaning, and that's what gives. And of course, value, the nature of value in its meaning, is based upon values being relative to each other anyway. They are relative in their nature, otherwise they have no meaning. That is the purpose of the meaning of number. And so, because of that, if infinity plus 1 is itself and minus 1 is itself, you can see in that kind of logical strain how it is true to say logically in kind of a general terms of a statement that infinity is, say, greater than itself and lesser than itself, you see, as distinct from the nature of any finite number, quantitatively speaking. I keep saying quantitatively speaking because we'll move on to it later, but unlike finite numbers, infinity is actually born first and foremost out of its qualitative nature. Its qualitative definition, its quantitative nature, the upshot of it being necessarily larger than a finite number, is actually a secondary property of its nature. It's not actually conceptually born that way as such, but I'll get onto that after. By its qualitative, well, I'll say for now, by its qualitative nature, I mean, in geometric terms, boundless or uncontained, which is, directly speaking, actually a qualitative statement, a qualitative property, not a numerical one. Strictly, the numerical upshot of that is that it, by virtue of being unbound or uncontained, of not having, of being directionless, at least, of being endless in at least one direction. So, in other words, a line without at least one end, which is a qualitative property regarding how many ends a one-dimensional object, a line, has. By regards of that, secondarily, then logically, it is therefore quantitatively bigger. I'm explaining it now anyway. Okay, it's bigger than any finite number, and specifically speaking, is bigger than any finite number by itself. Is bigger than infinity. Okay. But carrying on what we're saying more specifically about it being greater or less than itself, and then relativizing that statement in terms of its logical consistency with the finite numbers.